welcome to my channel. This is second part of the STA training intro that I started yesterday. The actual training gonna start next weekend, but I thought to give you a little bit of introduction of what I'm gonna cover. Okay, this second part is on the content, the different topics. So the slide that you're seeing right now, this is the only slide. And sorry, there's a lot of text in it, but I mix it with different colors to make it less boring. But yeah, this is pretty much the outline. Okay. During the training, I might tweak it a little bit, but we'll see. But overall, this is what I'm thinking of. Okay, I will start with where STA or static timing analysis fits. What is the difference between sign of STA and non-sign of STA? In an STA flow, what are the typical inputs and outputs? The concept of timing. Okay, we are talking about timing, but what is timing? Why we care about that timing? And what are the two important pieces of that timing? Slew, propagation, delay. And why we have delay? What are the sources of those? Then resistance and capacitance or RNC in active devices, transistor, inverters, because those concepts will be important for you to understand to apply them onto the gate. And then RNC in wires. Okay, what is timing path? What are timing arcs? We take a simple timing path and simulate it in SPICE, then understand different aspects of that. But what about the large designs? Can we do a SPICE simulation of large designs, lots of gates? Is that feasible? And that's where I would shift discussion towards now STA. What is STA? Why we do STA? How is it different than doing a SPICE simulation? Then when you have STA, you have a timing path. Then you need to constrain it, what we call constraining. And important parts of constraining is you have to define a clock. Then you have to define I/O constraints, concepts of endpoints, start points. Then you can have multiple clocks. And you have multiple clocks of different frequencies which are asynchronous to each other, stuff like that. Then you need to define some exceptions, multi-cycle paths, MCPs, or false path. After that, I will get into timing flows. There are three components of a timing flow. The timing flow the timing flows are simpler. They're not that complex. Okay, you have a design setup phase, you have update timing, and then you have analysis part. In analysis part, we will look into a standard STA timing report, understand different components of it. And after that, in the flow, we will look into ECO flows. ECO flows are very critical toward the last stages of fixing hold, fixing setup, fixing trans, gap. We'll talk about those. What is the difference between a block level flow and full chip timing flow? What are the key differences between them? Then within the timing flows, there are certain important concepts.